Hello and welcome to Controllers Tech. This is the third video in the W25Q Flash series, and today we will cover how to erase sectors. I planned this video to cover the write operation also, but the video turned out very lengthy, and therefore I have split them into two separate videos. This video will cover how we enable and disable the write, and how to erase a particular sector, or number of sectors. In the next video we will see how to perform the write operation on a page, or set of pages. This is the continuation from the previous video, where we saw how to perform the read operation. The data was stored at some particular locations, but in different sectors. As we will erase those particular sectors today, let's quickly see the result once again. The first set of data is stored on page 1, at an offset of 85. If we read the device starting from page 0, we get the data at an offset of 341. There is another set of data located in another sector, on page 17. Let's see the datasheet now. Here is the sector erase instruction. Along with sector erase, we can also perform 32 kilobytes, or 64 kilobytes block erase. Or erase the entire chip. Basically, sector is the minimum memory segment that we can erase. We cannot erase a single page, or a single byte. If you want to update even a single byte of memory, you need to erase the entire sector for it. The sector erase command erases the 4 kilobytes memory segment by setting all the bits to 1. But before performing the erase, we should first execute the write enable instruction. The method to send the instruction is the same. We send the instruction, followed by the 24-bit address. Let's see the write enable instruction first. The write enable instruction sets the write enable latch in the status register. This must be done before we perform a write operation, the erase operation, or update security and status registers. The instruction code is 6 hex. Let's write a new function, write enable. The procedure to send the instruction is simple. We pull the CS pin low. Send the instruction to the device. And pull the CS high. Let's give a small delay, just to be safe. Just like write enable, there is an instruction to disable the write. The process is the same, just the command is 4 hex. Now we have the write enable instruction, so let's erase the sector. The command is sent in the similar way we sent other commands. Pull the CS pin low, send the instruction along with the memory address, and then pull the CS pin high. Let's write a function to erase the sector, whose parameter will be the number of sector we want to erase. Define the data array to be sent. Now calculate the memory address using the sector number. Each sector contains 16 pages, and each page contains 256 bytes, so the memory address will be sector number times 16, times 256. Now before we send the command, enable the write operation. The command is sent in the similar manner we performed the read operation. The instruction to erase the sector is 20 hex. And we don't need to send the dummy clock in this case. After the data has been copied in the data array, send the data to the SBI. We need to send different number of bytes for both cases. After sending the command, disable the write operation. If you check the AC electrical characteristics of the device, you can find the time requirement to perform different operations. For erasing the sector, the maximum time required is 400 milliseconds. Let's give a delay of 450 milliseconds here. So this completes the sector erase function. Let's define it in the header file, so that we can call it from the main file itself. In the main file, we read the data from two different locations, and both were in different sectors. We will read the data, then erase the sector, and then read the data again. This will confirm whether the data was erased from the given location or not. Let's build and debug the code. Since we are reading data from the location where it is stored, we will get the data in the beginning of the RX buffer. Alright, let's run the code now. Here you can see we have received the data. Now run the sector erase command. And when we read the data again from the same location, we get FF hex. This means the data was erased from the first location, actually the entire sector 0 was erased. Now read the data from the second location, which is in sector 1. Here we got the data again. Now erase sector 1. And when we read again, the data is replaced with FF hex. This data is permanently gone now. If we reset the debugger, and try to read the data again, we will just find FF hex at those locations. So we have successfully erased the first two sectors. Erasing a sector is necessary, as I mentioned, this is the minimum memory segment that we can erase. When we perform the write operation, we need to erase a sector before writing data into it. This is because the write can be only performed on those memory locations, whose current value is FF hex. If a memory location already has some data, we cannot replace that data, we have to first erase it, and then write new data into it. We will cover the page write in the next video, which will be out in 3 days. This is it for this video. I hope you understood how to erase a sector. The link to download the code is in the description of the video. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.